Now we will learn about total internal reflection, very important section of this chapter and very important for board exams also. We already know that whenever a ray of light traveling from one medium and if it strikes the surface of an optical medium, then there is a reflection of light as well as refraction of light, and that phenomena where reflection and refraction occur simultaneously is called as scholars come on tell me partial reflection and partial refraction of light. And we also know that whenever a ray of light traveling from optically rarer to optically denser medium, it bends towards normal, and whenever a ray of light travels from optically denser to optically rarer medium, it bends away from normal. And in the last section we studied that if a ray of light traveling from optically denser medium to optically rarer medium at an angle equal to critical angle, then definitely angle of refraction will be 90 and the refracted ray will graze along the surface called as grazing emergence. So what I have done, I have considered a point object from which so many rays will come out, and this point object is kept in optically denser medium. So I will consider one of the ray coming from the point object which is incident normal to the surface, and we already know that for normal incidents I is 0, so angle of refraction will also be 0, and the refracted ray, it goes undeviated, right? So whenever a ray of light traveling from one medium to another medium, if it is incident normal to surface, then it goes undeviated. In second ray, I will consider that this one, right, this is traveling from optically denser to optically rarer, right? So some part of the ray will get reflected back over here, some part of the ray will get reflected back, and maximum ray will bend away from the normal. So remember, there is a reflection as well as refraction, which is a partial reflection and refraction, and in the first case also maximum ray will get refracted and a very few amount of ray will get reflected. So here the intensity of the refracted ray is maximum ray will come out of the surface, right? And here there will be some reflection and refraction, but what we observe that the intensity of the reflected ray will be more than the first case. So remember here, since the ray gets refracted, this angle which I am talking about, this angle is definitely less than critical angle. So if a ray of light traveling from optically denser to optically rarer medium at an angle lesser than critical, then definitely it will get refracted into the rarer medium, but some part of the light will come back. In the third case, if I consider this ray of light traveling from optically denser to optically rarer, if hits the surface at an angle equal to critical, so definitely the refracted ray will graze along the interface. This was the grazing emergence where angle of refraction was 90, but here also a part of the light will get reflected back, and again the intensity of this reflected ray will be more than the previous case. Are you getting me? So here the intensity of the reflected ray will be minimum and it will keep on increasing, whereas in the rarer medium the intensity of the refracted ray is maximum and it will keep on decreasing. So here the refracted ray is along the surface. So if a ray is traveling from optically denser to optically rarer at an angle equal to critical, so what happens over here? We can say grazing emergence takes place, and here simply what happens, refraction of light takes place. And what if a ray of light traveling from optically denser, so this ray of light, we can say, if I talk about this ray, this angle is more than critical. So if I talk about the fourth case where it was traveling from optically denser to optically rarer but at an angle greater than critical. Okay, since in the previous case the angle of refraction is 90 which is maximum angle of refraction, remember, cannot be more than 90. So in the fourth case, when angle of incidence is more than critical, what we observe that no part of the light will get refracted. In fact, all the light, I would say 100% of the light will get reflected back into the denser medium. So this is a special case where a ray of light striking the interface of an optical medium but no refraction takes place, the entire ray gets reflected back into the denser medium, and we can say 100% light comes back, and hence this phenomena is called as total internal reflection. So total internal reflection takes place only under certain conditions. One of the conditions is that the ray must be traveling from optically rarer to optically denser, but in all the four cases the rays were traveling from optically denser to optically rarer. Here reflection occurs, here reflection occurs, here reflections occurs, but these reflections were partial reflections. But when angle of incidence is more than critical, and when angle of incidence is more than critical, the entire ray gets reflected back into the denser medium. So only in the fourth case the total internal reflection phenomena will take place. The total internal reflection is a phenomena where the ray gets reflected back into the denser medium when it is traveling from denser to rarer. Remember, denser to rarer at an angle greater than critical. So I'll tell you two conditions. If I talk about conditions for total internal reflection to take place. So this question is of 2 marks, and you have to say, so the ray must travel from optically denser to optically rarer. The first condition says that ray must travel from optically denser to optically rarer, and second, angle of incidence should be greater than critical angle. So total internal reflection is a phenomena where a ray of light traveling from optically denser medium to optically rarer medium at an angle greater than critical. So if a ray of light is incident at an angle greater than critical while traveling from optically denser to optically rarer, what will take place is the total internal reflection. So total internal reflection is defined as the reflection of light completely into the denser medium while traveling from optically denser to optically rarer at an angle greater than critical. So now we have to remember 4 cases whenever a ray of light seems to be traveling from denser to rarer. First case is if you find out that if a ray is traveling, if it is ray traveling normal to surface, then definitely there will be no deviation, no refraction. The entire ray travels undeviated, right? And if an angle of incidence is lesser than critical while traveling from denser to rarer, refraction takes place. In fact, there will be reflection, there will be refraction, partial phenomena takes place. If an angle of incidence is equal to critical, you have to say angle of refraction has to be 90, that is grazing emergence takes place. But if an angle of incidence is more than critical while traveling from denser to rarer, the entire ray will get reflected back into the denser medium, giving rise to the phenomenon of total internal reflection. In the next section, we will learn about the total internal reflection of light through glass prisms, for which the critical angle is 42 degrees. Thank you.